My name is Bella, and I'm going to be going over question 19.1 from the additional Khan Academy Electrochemistry problems. This question states, calculate E naught, delta G, and K for the following disproportionation reaction done at standard conditions. A disproportionation reaction is one in which the same element is both oxidized and reduced. The equation given is 2 copper plus yields copper 2 plus solid copper. Your first step is going to be to determine which half reaction is oxidation and which is reduction. In this case, oxidation is the one losing an electron, so that half reaction is going to be copper plus yields copper 2 plus 1 electron. Your reduction reaction is the one gaining an electron, so that half reaction is copper plus 1 electron yields solid copper. In order to find E naught of the cell, we use the equation E cell equals E cathode minus E anode, where the cathode is the reduction reaction and the anode is the oxidation reaction. Looking at the table of given electrochemical potentials, the value of the anode is 0.15 volts and the value of the cathode is 0.52 volts. By plugging in these values, we get that E naught equals 0.52 volts minus 0.15 volts. The final answer is going to be 0.37 volts, and this is given in two significant figures due to the values given on the table. Next, we are going to calculate delta G of the cell, also known as the Gibbs free energy. This is found by using the equation delta G of the cell equals negative N times F times E of the cell. In this case, N is the number of moles of electrons transferred per copper ion, which is just 1. F is a constant known as Faraday's constant, and that value is 96,485 coulombs per mole. E naught of the cell is what we calculated in part A, which we found to be 0.37 volts. However, 1 volt is also equal to 1 joule per coulomb, so we are going to convert 0.37 volts to 0.37 joules per coulomb in order to get our units to cancel out. Plugging these values into the equation, we get delta G equals negative 1 mole times 96,485 coulombs per mole times 0.37 joules per coulomb. We can cancel out both for our moles and coulombs, leaving us with just joules. By carrying out the multiplication, we get that delta G of the cell is equal to negative 35,699.45 joules. However, delta G is given in kilojoules, so we are going to convert this to negative 35.7 kilojoules. We want this in two significant figures due to the values given in part A, so our final answer is going to be delta G of the cell equals negative 3.6 times 10 to the 1 kilojoules. For the last step of this problem, we are going to calculate K, also known as the equilibrium constant. To solve this, we can start by taking an equation that we already know, which is delta G equals negative RT times natural log of K. R is the gas constant and T is the temperature in Kelvin. However, we can also rearrange this equation to get K on the left side, which will make things easier in just solving for K, as K will be isolated. This will leave us with K equals E to the negative delta G divided by RT. R is the gas constant, which we know to be 8.314 joules per mole Kelvin. Since this reaction is at standard conditions, we know that the temperature is 298 K. In part B, we calculated delta G, which we found to be negative 3.6 times 10 to the 1 kilojoules. However, we're going to convert this back to negative 35,699 joules in order to get our units to cancel out. Next, we're going to plug in all of our values, leaving us with K equals E to the negative 35,699 joules divided by 8.314 joules per mole Kelvin times 298 Kelvin. K is a unitless constant, so we don't really have to worry about our values. However, K and joules will both cancel out. By carrying out the math, we get that K equals E to the 14.41, and our final answer is K equals 1,810,049.61. We want this in two significant figures and also in scientific notation, so our final answer is going to be K equals 1.8 times 10 to the 6th. Again, K is a unitless constant, so we are fine leaving this with no unit. In this video, we solved for E naught of the cell, delta G, and K for the disproportionation reaction that was given to be 2 copper plus yields copper 2 plus copper. We did this by first calculating E naught of the cell using E cell equals E cathode minus E anode and found this to be 0.37 volts. Next, we used the Gibbs free energy equation, which was negative NFE of the cell, to find delta G to be negative 3.6 times 10 to the 1 kilojoules. Finally, we calculated the equilibrium constant by using the equation that was rearranged to be K equals E to the negative delta G divided by RT, and we found this to be 1.8 times 10 to the 6th. Thanks for watching!